Yes, ma'am.
Okay. Give me a few seconds.
Yes, ma'am.
Shall I explain you here on this PDF? Whenever you need, we will do on whiteboard. Is that okay with you?
Okay, ma'am. No problem.
Okay. So our topic is Z transform. So what is Z transform? Let Xn be a sequence for, we can say for, defined for integers. Okay. Then the
Okay.
two-sided transform of sequence Xn is defined as, means Z transform of the sequence is equal to, we can say xz, which is equal to summation n is equal to minus infinity to plus infinity, because we are taking both negative and positive of xn into z to the power minus n, and where z is a complex variable in general. Okay.
Ma'am, can we do it in whiteboard? I
Sure,
didn't get it.
sure. Let us do. Just few seconds. Is whiteboard visible to you?
Yes, ma'am.
Z transform. What is it? Let x and b, they can give us like in this form, okay, in suffix, or can give us. You know about sequence, right?
Yes, ma'am.
Be a sequence defined for integers. In short, we can say integers, or we can say xn here is defined for n is equal to 0 plus minus 1 plus minus 2 comma plus minus 3 and up to so on. Then Z transform of the sequence is sequence xn is defined as, don't write anything, on the board?
Ma'am, it happened by mistake.
Okay, okay, it's okay. Defined as, or we denote Z from as by using this symbol as we are finding for xn. So we write it as is equal to, either we can write by using this symbol, or we can use this symbol also, or this is formula. N is equal to minus infinity to infinity and xn into z to the power minus n. And where z is a complex variable.
Okay, ma'am.
Okay. Now you got the definition?
Yes, ma'am.
Okay. Now next is next condition we have if xn is equal to 0 for n is less than 0, means for negative integer, if we have this sequence is equal to 0, value of the sequence is equal to 0 for negative integers, then Z transform can be defined as, just we take, because we are not taking here negative integers. So we have, we will take from 0 in a state of this infinity, okay? Minus infinity, we take this from 0, okay? Then Z forms transform of the sequence is equal to, this is denoted by this xz, or by using this formula, we write it as is equal to summation n is equal to 0 to up to infinity. Now we are taking only positive values of n into z to the power minus n. You got? Next. Now you will understand easily. We can share the screen. First for unit sample sequence and unit step sequence. Shall we? Now you got definition of this Z transform.
Got it, ma'am. Got it.
Okay. Few seconds, huh? I'm going to share the screen.
Okay,
Whenever
ma'am.
you feel you will not understand, then I'll explain you on whiteboard. Okay. Unit sample sequence. See, unit sample sequence is defined by, means denoted by SN. Okay. and we take values as. We will take the values of this sample unit sample sequence in question, okay? Like you can say formula or concept we will use in questions this, okay? Unit sample sequence is denoted by Sn and which is defined as sequence with values. We will take Sn is equal to 1 when n is equal to 0 and 0 when n is not 0, okay? And for unit step sequence, it is denoted by U1 and we will take U1 is equal to 1 when n is greater than or equal to 0 and 0 when n is less than 0. Got it?
Okay, ma'am. Okay.
And S n minus k is equal to 1 when k is equal to n. Okay. It
Okay, ma'am.
means, if both are equal, then we take it as equal to 1. And if they are not equal to, then we take it 0 for S n minus k. And for U n minus k, when we have n minus k is greater than or equal to 0, then we'll take it as 1. And 0 for when difference of them is less than 0. Okay. Now
Okay,
next
ma'am.
function. You got till here? Because it
Yes,
will
yes.
take time to write only. These are simple things, okay? So whenever you
Yes.
feel any problem, then we will do on whiteboard. Which
Okay,
you
ma'am.
can understand easily here on PDF, then we will do on PDF, okay?
Okay.
So next is, if ft is a function defined for discrete values of t, and where t is equal to n into capital T. And here we are taking n is equal to from 0, 1, 2, 3 and up to infinity, and t, capital T being sampling period. Then Z transform of ft is defined as Z of ft means in a state of that sequence, we are taking this function ft, okay? And
Okay,
t is
ma'am.
equal to, we are taking n into capital T. T being a sampling period, and we are taking as like we can say whole numbers. Okay, started from 0, 1, 2 up to infinity. Got it?
Yes, ma'am.
Or we can say non-negative integers also. N is here non-negative integer either, or we can say whole numbers also. You got?
Yes, ma'am.
So here in a state of that sequence, we are using here ft. Okay. So that time we were using xn. Then we have taken here xz, and here now we are taking ft. So now we are taking like z transform of ft. So here z ft is equal to fz. You got this step?
Yes, ma'am. Yes, ma'am.
And in a state of small t, we are taking nt. Here in summation, n is equal to n is equal to 0 up to infinity, and f n t into z to the power minus n. So meaning is that when we find z transform of any function or a sequence, then we will write inside of summation the same thing, and into z to the power minus n we will take always. You got now?
Yes, ma'am.
Now let us know about properties and theorems of Z transform. So notations, as we have discussed, ZFT is equal to FZ and ZXN is equal to XZ. Okay,
Okay,
if
ma'am.
we are finding for sequence, then we can write it as XZ also. And if we are finding for function FT, then we will write it as FZ. These are notations. And now let us do first theorems. First theorem, the Z transform is linear. That is, it is so simple. If we have coefficient of, like if we have like coefficient of ft and another function gt. Then if we find Z transform, then we take coefficient outside of this. You got? See,
Yes, ma'am.
we have coefficient of like coefficient of ft is a and coefficient of gt is b. So we need to prove it. We'll take coefficient outside of this and Z transform of ft plus b into Z transform gt. So let us use the formula to prove it. See, it's so simple. If you feel any problem, then we will do on whiteboard. Even it is so simple. See, we are finding Z transform of A ft plus B gt. Obviously, we will use formula, right? And we'll take
Yes, ma'am.
summation with both. So obviously, as we know, we take or only variable part inside of summation and take coefficient, or we can say constant part outside of this constant. Okay, because we can't use value of n here, right?
Yes,
A is
ma'am.
constant. So obviously we are taking summation n is equal to 0 to infinity. So A doesn't contain any n, right? So we are taking outside A and B. You got this step?
No, ma'am.
See, this summation you got, this one?
Yes, yes.
Yeah. So just we have taken summation with both, right?
Okay.
And just take outside coefficient A and B, nothing else. You got?
Okay.
Got it?
Yes, ma'am.
Yes.
Yes, yes.
So by using formula summation A into summation n is equal to 0 to up to infinity f and t into z to the power minus n is just fz. Got it? By using
Yes, ma'am.
definition. And similarly, we can write b into summation n is equal to 0 to infinity into g and t into z to the power minus n will be obviously gz. You got? By
Yes,
using
yes, yes.
instead of ft, obviously we are using here gt. Got it?
Got it, got it.
Yes. So I'm telling you one, you can say a trick or tip. Whenever we have like any sum of functions, even having coefficient or don't having coefficient, we take formula like by using, like if we have sum, then we'll take sign of addition. If we have difference, then we can use minus sign here. And even we have if coefficient, then take outside of summation, right?
Yes, ma'am.
Not only for Z transform, for any type of transform or any formula, even for any type of like if we are differentiating, integrating, and doing any type of transformation even. So if we have coefficient, then we take obviously outside. And if we have sum of two functions and we need to find transformation, obviously we can split them by using plus symbol as we have done here. You got? By in
Yes,
this
ma'am.
step. Okay? You got?
Yes, ma'am. Got it.
Right. Similarly with sequence. Similarly, we are doing with sequence. In a state of FTGT, we have here xn and yn.
Yes.
You got it?
Yes, yes, yes.
And if we are finding for Sn, unit sample this sequence. Okay? If we are using for this, then see. Okay. So as we have taken unit sample sequence, its value is 1 when n is equal to 0.
Yes, ma'am.
Okay. So we have 1 here. You got
Got
why?
it.
Because in a state of Sn, we put 1 and also we are taking z to the power minus 0. Then it will also be 1. You got?
Got it. Yes,
Yes.
ma'am.
Whenever you feel that you need explanation on whiteboard, then you can tell me, okay?
Okay, ma'am.
Next theorem is Z transform of Un. So now in a state of Xn or Ft, we are using Un. Okay. So by definition, if n is equal to 0, then its value is 1. N is greater than or equal to 0, we have it is 1. You got?
Yes, ma'am.
Yes, we have in definition. Yes. So we left with only z to the power minus n, right? And we can write z to the power minus n, as you know very well, 1 upon z to the power n. And now we can put value of n is equal to 0 to up to infinity. Then we will have this expansion. Are you getting me?
Yes, ma'am.
This expansion we can get. And we can write it in terms of, binomial expansion. You got? We have
Yes, ma'am.
formula of binomial expansion. We have when we have like 1 minus whatever we have here, we have 1 upon the z. So obviously we have the power of z in denominator and having power minus 1 also. Then we have all terms positive. If we have both means negative sign on both places, even in power or in here, terms between like these two. Do you remember?
Yes, ma'am.
Yes. So we can write in terms of binomial expansion like this and can simplify. Okay. So when we take it, when we take this expansion as when we have absolute value of 1 upon z is less than 1. Okay. Because only when we
Okay.
have difference positive, if we have less than, if we have greater than 1, obviously we will have negative value, right?
Yes, ma'am.
Yes. Or we can simplify further as you got.
Yes, ma'am.
Okay. Or we can write in this form by taking inverse. When absolute value of z is greater than 1. You got? Means
Yes, ma'am.
this is for sorry. Just a second. We have done this. Unit sample for this unit step sequence UN. Yes, we are doing for this unit step sequence UN. And we are doing for this. Okay. Z transform of
Yes,
unit
ma'am.
step sequence. Yes, this is. You got till here each and every step?
Yes, ma'am.
Okay. Check if. Next. As we have done Z transform of Ft is Fz. Then Z transform of a to the power n into Ft is equal to Fz over n. We need to prove it. Okay. So let us do. So by using definition, like we have coefficient a of Ft a to the power n. But we don't take this outside, because we have a to the power n. So we need to put a value of n here and can find the expansion. Okay. So here we are taking by using formula summation n is equal to 0 to infinity a to the power n. F in a state of t, we are using n cap into capital T into z to the power minus n.
Okay, ma'am.
And see here, we have z to the power minus n, and we can take this because we need to prove it z over n, z over a. So to find that, because if we have here z to the power minus n, then we can write it as fz, right? Instead of z, if we have z over a, then we can write it as fz over a. So here we have a to the power n. If we take in denominator by taking negative power of n, are you getting me?
Yes, ma'am.
Okay. So we can write it as f n t, summation n is equal to 0 to up to infinity, f n t into z over a and whole power minus n. So here we have, instead of z, we have here z over a. So we can write it as f z over a. You got?
Yes, ma'am.
Yes. Good. And similarly, we can do for sequence also.
Ma'am, can we do the rest tomorrow?
So you don't have time or want to go?
Ma'am, I have some college work as well now.
Okay.
Okay, ma'am.
Alright.
Thank you, ma'am.
Okay.